Okay, Jim, hopefully you can hear me. I don't have my iPad stylus because my 3-year-old has taken it from me, so I'll use my finger. Anyway, I guess the two things I mentioned in my email, if you have time to talk with Ara about possibility including error in the major axis, well, basically in the observations from the CMIST data. I don't know if it's possible. If we can look at just maybe look at one of the raw CMIST to see if something could be done with that, to put error bars in there. I think that would be useful. People tend not to do that. I'm not sure why. So the other thing is smoothing the ADCP transect data. As I mentioned in my paragraph in the email, he's done some work. His smoothing scale seems way too big for me. And then when he really started describing it, I realized there was some of the things he was doing, I think maybe need some adjustment. So he's working. I gave him some ideas along those lines, which I guess he's working on now. But anyway, I'll just sort of summarize. So if a transect looks something like this, ideally the boat drives exactly that transect. But these ADCP calculations were there was a lot of motion in the boat. I think that the pings, or the data at least, is about 10 seconds apart, if my memory serves me correct. And so the actual distance between measurements works out to about 30 to 50 meters. It seems to be in that range in all the observations, and varies quite a bit. Even in one transect, even from ping to ping, it seems to vary. Part of that seems to be the ship track, so let me just extend this all the way over. And so instead of going on a straight line, you could think of the pings as being something like, let's say it might drive something like this, and then it goes on from there. And ours essentially processed each of these. Think of each of these segments as the velocity being constant, and each of those segments that I drew ends up being a single vertical column in the two-dimensional transects. I know I talked with Ara a while ago about how to collapse this into, the straight exact transect. I'll just do with a blue line here. And I wish I could remember where that went. We had a lot of discussions about it. Part of it, I think, is it's not monotonic. You can even see in this section here, if you were to project all that into the blue plane, along the normal to the blue plane, you'd already have a non-monotonic, if that makes sense, situation, even in what I drew. And so this occurs quite a bit in this data. So I guess what he ended up doing was, I'm trying to think about this for a second, he was looking at each segment, and then along each segment he would sort of draw a normal. So that's a normal to that segment, that's a normal to that segment, that's a normal, that's a normal, that's a normal, and was looking at the velocity across that normal times the edge length, and essentially projecting that into 2D. Not projecting, actually, and just unwrapping that into 2D. So each of those segments represents a distance in 2D, the length of the segment, and then the velocity normal to that segment is the velocity that ends up in 2D. So if this closes back eventually to this other segment here, to the other endpoint, then the mass flux is going to be fine. Energy is another consideration, but what happens is, so then what he does is he processes the observation data that way. Then what he did to compare with the model is he interpolated the model results from these points. So wherever these green vectors, the root of these green vectors, I think, which I'll make just a little purple dot, hopefully you can see that, he grabs the model results interpolated to that point and sort of does the same thing, uses the same normal, projects the model velocity onto those green lines, and does the same kind of reconstruction. So what you end up seeing is noise in the model, because obviously the velocity magnitude is going to vary strongly. If, for example, you had a current in here, if all the flow is uniform, like this, and parallel, then if you look at these projections, you're going to have very different velocities. One of them looks to be almost zero, this one right here. So you get this kind of oscillations that is occurring. So I asked him to go back. I hope this makes sense, but I asked him to go back and look back at reprojecting. So maybe first splining the observation data at some scale in order to remove, keep it from being monotonic. I mean, perhaps we could just take a data point out. I don't know. To make sure to make it monotonic, so it can weave its little path, but as long as we collapse it down on the blue line, that it results in a monotonic signal, and then and that would be fine. To be honest, I mean, the time it takes to traverse this whole section is in a matter of minutes. It's not very long, just 10 or 15 minutes. So I don't see the problem. The monotonic part doesn't even matter. I don't see why just projecting this onto the blue line would be such a problem. But anyway, I'd rather reference a single line somehow with the data. So I think he's working that up. So if you can speak with him, I don't know what your thoughts on this are. I was a little surprised to see what was happening. I gave him 3 goals. I'm just trying to remember what they were. One is the model, it should not show noise. I mean, it shouldn't show noise. So whatever processing we're doing shouldn't end up with noise in the model. The other was a justifiable spatial scale. We talked about in the meeting using a filter. I think you mentioned it was the same order with the model scale, which is 50 meters. That's about the same scale as the observation data, just for your reference. So whatever interpolation or splining or smoothing scheme we use, we have to say why we used it and why that would be fair, because we are treating arbitrarily the observation data. I forget what my third criteria to him was, and hopefully he recalls it. It was, I don't remember. I'm sorry. So I think it was a consistent energy flux. So I think whatever represents an energy flux across a straight transect, however we process this data, has to represent the true energy flux across what would be the straight transect. I think that was the third criteria. Anyway, I'll just put this in YouTube. If you have time to meet with him tomorrow, if you have any thoughts about these, I asked him to make a PowerPoint of both his CMIST recap to start a discussion about including observation errors. I also asked him to make a PowerPoint about this. We were going to send those to you eventually, so this may be premature, but I'll send him an email to see if he's ready to meet with you tomorrow, and he may not be, and I'm not sure if you're going to end up with enough time anyway, but just a thought.